Hi everyone, I'm Jonathan Campos, a Senior Product Marketing Manager focused on observability, and I'm really excited to be here with you today on today's Tech Talk. Today's Tech Talk, DevOps Edition, is focused on maximizing the performance of your Kubernetes deployment. Tech Talks are a series of short webinars that are deep dives for technical practitioners. I value your time today, and I'm really excited to share with you some of these best practices so you can leverage them in your daily role. So our agenda today will start with talking about how Splunk Infrastructure Monitoring makes monitoring Kubernetes easy. We'll take a look at some key metrics to look for when monitoring Kubernetes, and then we'll go into a demo on setting up Splunk Infrastructure Monitoring to monitor your Kubernetes deployment and look for some of those key metrics that we're going to talk about. We'll then also go into additional resources to continue your Splunk journey. Let's get started. So when it comes to Kubernetes monitoring, Splunk's Observability Cloud's infrastructure monitoring really makes it simple to monitor Kubernetes. We use the Splunk Open Telemetry connector to gather metrics of our Kubernetes deployment to quickly begin monitoring for possible performance and deployment issues. Splunk Kubernetes Navigator is the easiest way to understand, monitor, and troubleshoot Kubernetes clusters and deployed workloads. It starts with the dynamic cluster map, which is pre-built and is curated visualization, really helps to understand the health, interdependencies, and performance of Kubernetes clusters. Your logs are also in context. What we want to do is eliminate context switching and accelerate root cause analysis. No one wants to go trying to find that needle in a haystack. The Kubernetes Analyzer is also a huge help with its AI-driven analytics to automatically bring insights and recommendations to expedite triaging and troubleshooting so you're not consistently worrying about where to just start looking first. You also get fully automated Kubernetes monitoring with zero-touch configuration, and we're going to see that in the demo. And the automatic discovery of your Kubernetes deployments and containerized services will magically just begin working. Now, when it comes to monitoring Kubernetes, there are several metrics to keep in mind. First and foremost, we want to take a look at pods that are in a pending status. This could potentially mean that we have inadequate resources, or pods that are in a failed status. This could potentially mean the wrong image is used for pods, or we have the wrong command arguments that are passed over to the pod. And also containers with high restart counts, which means that the application inside the container just keeps crashing. And over on the node side, where we may have nodes that are not ready, which could mean that they're out of memory or disk space, or nodes that are experiencing high CPU or memory. These pods could not have resource limits that are deployed on these nodes, or you may not have enough nodes to deploy all of our pods, which would mean that we would of course have over-provisioned resources. So all of this has to be kept in mind. All right, so let's get started with the demo so you are ahead of the curve with your Kubernetes monitoring. So let's break down this environment here. So here we have the Splunk Observability Cloud console. We have an e-commerce site that happens to be down right now, and it's just a little inconsistent. And we also have a load generator tool, and this tool will simulate load on our e-commerce site. This particular e-commerce site is running on a Kubernetes cluster that already has the Splunk Open Telemetry connector already installed, and I'll show you guys that. We'll do a kubectl get pod so you can see that it is active and up and running. And what we're going to do is we're going to go ahead and use this tool to start generating some load on our site. We'll simulate 1,500 users at a spawn rate, to kind of keep it simple, of 100 users per second. So we'll start that. That's just really going to start to really overwhelm the site, or potentially just keep the site up and running. It depends, because we're not sure if we have the right resources on our site. So in the meantime, we also have this Kubernetes cluster that happens to have nothing installed. And I want to use this cluster here in particular so that I can show you guys. And let me actually clear the screen here and run kubectl get pods. So you can see that there's no pods installed in this cluster now. So I can show you guys the installation of what it takes to install the Splunk Open Telemetry connector. So let's do that now. So here on our home page in the console, we're going to click on this hamburger menu. We're going to go to Data Setup. And then when we click on Data Setup, once this loads here, we're going to click on Kubernetes. and we're going to click on Add Connection. Once we click on Add Connection, you'll see we have a series of details that we have to provide the console, starting with specifically the access token, which is used to authenticate with the service, right? So we can use either our default access token, which we'll do here, or you can choose one of your own if you choose to generate your own access token within the console. We'll then need a cluster name, and we're going to call this one, just to really quickly identify it, we're going to call this one Tech Talk Without Data. Kubernetes cluster with data will be the one running that e-commerce site that's already installed. And we want to make sure that we have enough data so we can show you guys everything you need to see when it comes to monitoring a production Kubernetes cluster. And then we're going to choose our provider, and our provider could potentially be any one of these 3 cloud providers, or you can choose other. And what this does is that this allows us to quickly identify where our Kubernetes clusters are deployed. So say we choose Amazon Web Services, then of course we'll choose Amazon EKS for our distribution. In this case, we'll just leave other for both of these due to the fact that this Kubernetes cluster is deployed on my local machine. And we're not going to choose a gateway. We're going to deploy it locally to each cluster onto a gateway. Next, we're going to go ahead and hit Next, and you'll be presented with a series of steps to install this particular connector. So starting with the first step, we'll add the repo to the machine, or to the machine hosting the cluster. And this is actually going to use Helm because we do leverage Helm charts to install the Splunk Open Telemetry connector. So we'll paste that there. That's going to install the repository. And just before we continue here, I want to make sure that before you do install the connector, you want to make sure you do have Helm installed. And you can do that by quickly typing in your console Helm version, and that'll quickly tell you what version you have of Helm. And of course, if you see some type of unusual error, then of course you may need to reference the Helm documentation to quickly install Helm on the machine running the Kubernetes cluster. All right, so now that our repository has been added, and we did that up here, the next step is to update all of our Helm repositories. So let's select that, and then we'll paste that. So that's all done. And then the last step is, of course, to install the Open Telemetry connector here. So we'll copy this, and these settings that we've specified here within this command are actually reflective of what we selected here in Configure Integration. So let's go back here. We've copied that code. We're going to paste that, and we're going to hit enter. And we'll give that a second. And as you can see, the Splunk Open Telemetry connector has been installed. The collector is there, and let's confirm. We'll clear up the screen here, and we'll do kubectl get pods, and we can see that it has been installed, and the container here is actually creating. So let's give this about a second or two to make sure that the deployment is successful. And that looks good. So we should, of course, see this particular empty cluster within the console now. So let's go ahead and hit next here, and we'll go ahead and hit that hamburger menu, and let's just go directly to our infrastructure. So here in our infrastructure, we'll select Kubernetes, and we'll hit this little down arrow. We can see that we actually have our Tech Talk cluster with data. That's the one that's running that e-commerce site. And then we also have the Tech Talk without data. Let's take a look at that Tech Talk without data. And you can see that that is the installation to begin monitoring your Kubernetes cluster. That's all you need to do. So you can actually dive into the details. And what we're going to do is we're going to dive into the details with the cluster that has the e-commerce site already there. So we'll hit this little down arrow here, and we'll select the Tech Talk with data. And you can see here that this is our dynamic cluster map. So we can see that we are experiencing some errors. We can see that we've had a few container restarts already. This particular pod happens to be the recommendation service, and we've already had a few restarts here. Doesn't look good here. We'll definitely dig into this a little deeper. But again, this dynamic cluster map is going to change as your sites or deployment changes, rather. So you can see here, we also have an overview of our nodes, which I only have one node deployed. We can see the CPU used, the memory used, the disk that's used, the network traffic, how many host cores, and so on and so forth. So we can see all of that in action. We can also see the different workloads that are deployed in our environment, and we can quickly, of course, filter by namespace. We can filter by workload type. And of course, you can see up here, we already are filtered by the Tech Talk with Data Kubernetes cluster. And then the next detailed tab here is our node details. So what's going on in this particular node, what pods or what containers are running? We can see all of that right down here. We can see the memory used by pod, and we can see the CPU used by pod, the CPU percent used by pod. Pretty much everything we need as an overview is provided here. And we can, of course, filter by node. In this particular case, in this cluster, in this deployment, we only have one node. So we would just check that one node and we can add that filter. Of course, we're going to see the same information, but just to show you guys that we can filter like that. And then, of course, we have the workload detail. Now, one great place that I like to look is the workload detail, as well as the pod detail and the container detail. We're going to go through that in a second. But the workload detail kind of tells me what my deployments look like. So we can easily see that the percentage of CPU that's being used, how many active containers this particular workload contains, and all of these that you see here are actual deployments, right? And what I want to do is I want to reflect that here in just a second. What I want to do is go quickly to the console here, and you can see kubectl get deployments, deployments, and you can see that all of my deployments are reflective there. So you can see all of that here. And then, and of course, this is for the default namespace. We can filter by namespace here if we choose to. In this case, we saw on the console there what was part of our default namespace. And here's the workloads there that are reflective here. All right, so moving on, we can see the pod details. And this is our pods that actually run our containers here. And we can see all of the details that we want to see here. So you can just quickly dive in and just really take a look at everything that's going on. So let's take a look at one key metric here. In specific, one thing that pops out to me is CPU percent of limit. So in Kubernetes, we have the ability of setting for each one of our pods resource limits. How do we know that all of our pods that are deployed in this Kubernetes cluster actually have resource limits set? Well, it's simple. You can quickly scroll down here and you can see that most of these have some limits set up because we can see CPU percent of limit. In this case, let's scroll down to, let's say, our Redis server. It's using about 0.2% of its limit set CPU. But the cool thing is you can also see that maybe some developers maybe didn't set a limit for a particular service. Let's take a look at which one may have not been set. We'll scroll here and let's take a look. The email service here kind of has the ability of taking unlimited resources here. So this could potentially be a problem if this particular service is having an issue. So we want to definitely set limits, and we set those limits within our Kubernetes deployment files. But moving on to kind of take a look at the console here, we can go into container details and actually see some detailed information about our containers. And I know that we're going to be running short on time here, so I want to go quickly back to the dynamic cluster map. And here at the dynamic cluster map, you can quickly zoom in to actually see all of your pods and all of your containers running. And you can also go into detailed info for the actual node. And you can see all of that here on the right-hand side, and you can expand that, and that'll immediately take you into node detail. But going back over to the map, which is what I like to call my starting point, I'm going to select how about the email service pod here that we were seeing that didn't have any limits. So let's find that pod here. Here it is. And we can scroll down and we can actually see those details here and everything that we want to know about this pod here. And then we can go over to Analyzer, and Analyzer will provide us with some suggested filters that we may want. So let's click on the actual node itself. And let's go over to Analyzer. And in this case, right now, we can see that we have no patterns that have been discovered. But what will happen is certain patterns will be discovered based on the given analyzer. The analyzer will start looking at this deployment. And as it goes through this deployment, it'll start to recommend certain filters. For an example, pods that have a failed status, or pods with a pending status, or pods with unknown conditions. And you can quickly just select them here. So that's the beautiful thing about the Kubernetes Analyzer that's built into Splunk Infrastructure Monitoring. So very, very cool tools to really just dive deep and really look into some of those key metrics, like your CPU memory utilization of your nodes and your pods and so forth. A great, great tool to have in your environment, for sure. So I want to thank you so much for attending today's Tech Talk, and I really hope that you enjoyed that demo. And before we wrap things up, I want to quickly share some resources that are available to you to continue your journey with observability. You'll receive these assets in a follow-up email, and as well as the recording of this presentation. And don't also forget to take advantage of our incredible community that Splunk has for our users. And our community site is great. You can definitely have some great conversations and search for answers in the Kubernetes monitoring section, and continue the conversation for this talk within the discussion section called Tech Talks. So definitely check that out. I also want to mention that before we go, that we're currently working on increasing our presence on peer review sites like Gartner Peer Review. If you have a second, we'd love your review, and really appreciate it if you can leave us one. With that, we really appreciate you taking the time out of your busy schedules to join us today. Be sure to tune back in for further future Tech Talks. Now let's open it up for Q&A.